This video goes over adding and subtracting rational expressions. Adding and subtracting rational expressions is the same as adding and subtracting any type of fraction. You need to find a common denominator. So let's do some practice with numbers and then we'll work our way up to variables. The first fraction I'm adding is 1/7 plus 1/3. I need a common denominator. I can find that by multiplying the two bottom numbers together. So 3 over 21 plus 7 over 21, which gives me a final answer of 10 over 21. Let's do another example with subtraction. Now my denominator are 5 and 7, so I can multiply those together to find a common denominator of 35. And on top, I would have 7x minus 5x, which simplifies to 2x over 35, and I can't simplify that any further. Our next example that we're going to do now has a variable in the denominator. We can still find our common denominator in the same way by multiplying the two bottom numbers together. So my common denominator is 4y. And in order to make an equivalent fraction, I'm going to multiply the top by whatever I multiplied the bottom by. So the first fraction, I multiplied the bottom by 4. So that means that I need to multiply the top by 4 as well. In the second fraction, I multiplied the bottom by y. So I need to multiply the top by y as well. So now I can add the top because I have a common denominator, and then state my restrictions that y can't equal 0. Let's look at another example, this time with variables in both fractions. So what I want to do is find my lowest common denominator. And so in this case, I can actually change both fractions to be out of y squared. You could multiply together and find a common denominator of y cubed, but that would be like if you have 1/3 and 1/6 and you used a common denominator of 18 instead of 6. So this is a little bit shorter. We won't have to do any canceling at the end. So my first fraction, I haven't changed at all because the denominator is already y squared. The second fraction, I multiplied the bottom by y, so I have to multiply the top by y as well. So my numerator is 1 plus y, and my denominator is y squared, and my restriction is that y can't equal 0. In example E, here in my first fraction, I've got p on the bottom, and then I've got 4p on the right-hand side. So in this example, my common denominator is just going to be 4p. My second fraction, I don't have to change at all because my denominator is already 4p. In my first fraction, I've multiplied the bottom by 4, so that means I also need to multiply the top by 4. Now that my denominator is the same, I can subtract the numerators, rewrite with one denominator, and then state my restriction. Our last example here is a little bit more complicated because now I've got two variables on the bottom. What I'm looking for is what I can multiply both of them by to make them the same. So my common denominator is going to be x5 y cubed. So my first fraction, so x5 y cubed is the denominator. In order to change from x squared y cubed to x5 y cubed, I had to multiply by my denominator by x squared. So that means I have to multiply by numerator by x squared as well. In my second fraction, to get to that new common denominator, I had to multiply the bottom by y squared. That means that I need to multiply the top by y squared as well. Now I have two equivalent fractions with the same denominator. I can add them together, rewrite with one denominator, and then state my restrictions that x can't equal 0 and y can't equal 0. Let's do some more practice finding the lowest common multiple, which is going to help us to find our common denominator when we work with more complicated expressions. So the lowest common multiple is the smallest expression that goes into both terms. In example A, I'm going to start with my numbers. The smallest expression that goes into both terms is 3. The smallest expression that goes into both of my x's is x squared, and y's would be y squared. So that would be my lowest common multiple there. In my second one, now I've got 3 things to consider. I'm going to start again with my numbers. The smallest number that goes into 3, 2, and 1 is just 1. Looking at my m's is also 1m. And then finally the n's is also 1n. In my third example here, again, I've got 3 things to look at, and they look different because they are a binomial and a trinomial. So what I'm actually going to do is I'm going to factor my trinomial as x minus 4 and x plus 6. So now what I can see is that my lowest common multiple is actually x minus 4, because that bracket, that factor appears in both of my options there. So let's do 2 more examples with a little bit more complicated expressions. It's a little bit trickier to find that lowest common multiple or lowest common denominator when you have a binomial. So in my first example, the denominator of my first fraction is x minus 2. Denominator of my second fraction is x minus 1. My lowest common denominator I can still find by multiplying those 2 together. So my new common denominator is x minus 2 and x minus 1. And then in order to create equivalent fractions, I have to multiply my numerator by whatever I did to the bottom. So in my first fraction, I multiplied the bottom by x minus 1. So that means I'm going to do the same thing to the top. In my second fraction, I multiplied the bottom by x minus 2. So I also have to multiply the top by x minus 2. So now that I have the same denominator, I can add them together. And rewrite with one denominator. Now the bottom is as simple as it can get, but I should expand, collect like terms, and then factor the top. So expanding my first 2 binomials, I'm going to get x squared plus 4x minus 5. Expanding my second 2, I'm going to get x squared minus 5x plus 6 all over x minus 2, x minus 1. Collecting like terms gives me 2x squared minus x plus 1 all over x minus 2, x minus 1. And I can actually factor my numerator, or I can check and see if I can factor my numerator, but I can't factor, so that's as simple as I can get. I've successfully added those 2 rational expressions, and the last thing that I need to do is state my restrictions. X can't equal 2, and x can't equal 1. Let's do a final example with subtraction. And here what I'm going to notice is that my first denominator is pretty complicated, so I'm going to factor first. I have a simple trinomial here, and I'm going to factor it as x minus 5 and x plus 3. My second denominator I can also factor by taking out an x, and then I've got 5 minus x, which is almost the same as this bracket here. So instead of just taking out x, I'm actually going to take out negative x. And then if you remember that trick that we did before, that is going to flip the negative signs in my bracket and give me the same as this first bracket here. By doing that, I've done two things. One is I've got two negative signs that I can replace with a positive. The second is that I've now got a common factor in the denominators, so it's easier to find my lowest common denominator. What I can see is that I've got x and x minus 5, and then on the first one I've got x minus 5 and x plus 3. So my first fraction, in order to make it the same, needs to be multiplied by x on the bottom and x on the top. And my second fraction, in order to make it the same, needs to be multiplied by x plus 3 on the top and the bottom. So now I have the same three factors in each fraction. Gives me a common denominator so that I can add them together. So x plus 3, x minus 5 on the bottom. And on the top, I'm going to expand and add together at the same time. I've got x squared plus 5 plus 3x plus 9. Collecting like terms, I've got x squared plus 3x plus 14. And let's see, I should have an x here, which would give me 8x and 9. And then x times x plus 3, x minus 5. I can check and see if I can factor the top. I can't in this case. So now I have my final simplified answer, and the last thing for me to do is to state my restrictions. X can't equal 0, -3, or 5. And those are some examples of how to add and subtract rational expressions.